Good morning, everybody. We're just going to wait another minute or two for the last couple of people to sign on, and then we'll get started. Make sure you have the notes ready that were posted yesterday afternoon. All right, good morning, everybody. I hope you guys all had a fantastic weekend. I hope that you are keeping up with your math homework on top of having a fantastic weekend. So over the weekend, I gave you feedback for assignment 4. So we're going to go over a couple of those problems if you have any issues with that. Also on Friday, you got assignment 5. So we'll go over any questions you're having with that as well. There are a couple of things that I was noticing with the assignments that were common mistakes that were popping up. So I want to address those to everybody at the same time. And then we'll get into the new material. The new material today is a little bit different than it was before, just because of the notes that I uploaded. So you might notice that there are a ton of pages of notes, but we're not going to cover them all together. And I'll explain that a little bit more when we get into the notes themselves. For right now, as per usual, I'd like you to post in the chat if there are any questions, or say them out loud, any questions that you want to go over, either for the assignment 4, assignment 5, or the handout that I gave you on Friday or on Thursday. Okay, so I see some questions starting to pop up. Take a minute or two to ask some questions, then we'll get started. Okay, so far I have the problems on assignment 4, and then I have assignment 5, number 1. Anything else? Okay, I will try to go over as many of assignment 5 as I can. Okay. So just before we get started on those questions, there are just a couple of things that I noticed. Can everyone hear me properly? Is it a bit better than normal? Or is it too loud or anything? Everything's fine? Okay. So just a couple of things that I want to go over before we get started, because I noticed some common mistakes in the assignments. So first of all, you all had assignment 4 feedback. So you will see the comments on the side. You can go through those. But like I said, there are some general things that I noticed too many people doing that I need to address on a bigger forum. So if you know this already or you understand it, that's fine. But if not, please take a look. So the first thing I want to cover is this. So this was in one of your problems. So when you factored it, if I'm not mistaken, it was assignment, it was class 4 assignment 1. When you factored x to the 4 minus 16 into x squared plus 4 and x squared minus 4. Now the first thing I want to talk about is the difference of squares. This is a difference of squares. This is not. What does difference mean? Well, difference means subtract. That's a T. This is a subtraction. This is not, meaning this is not the same thing as x minus 2x plus 2. This is equal to x minus 2x plus 2. So think about difference of squares. So, but the important thing is it's a difference of two things that are squared. Again, here we have the subtraction. That's why we were able to split this. So this, if we look at x squared plus 4, we go through our list of tools to be able to factor. So there is no GCF. I can't do grouping because there's only 2 terms. I can't do product sum because there's only 2 terms. And it's not a difference of squares, sorry. So this is actually factored. And then what ends up happening in that problem is you had this term on the top and on the bottom, so they just canceled out. So some of you got to the right answer, but did wrong work in the middle, because if you factored this incorrectly or factored it at all, which was incorrect, then it canceled out with whatever you did on the bottom. But that's not correct. So you would actually, if this was in a long question, you would lose points for that. The other thing I want to talk about is when you are using this as a restriction. If you're using this as a restriction, you set it equal to 0 and you solve, okay? You get x squared equals 4, negative. Can you square root a negative number? Like your next step would be this, but that's impossible. You cannot square root a negative number. That doesn't work, which means that there's no restriction here. It does not apply. So that was the clarification for x squared plus 4. The other clarification I wanted to look at is this. So in assignment 4, number 3, that was one of the questions that we'll go over in a second. But for just to start off, I want to make sure that everyone is clear, okay? This does not go to this. You don't just put the 2's in here. That is not okay. When you have a perfect square trinomial, you have to use your perfect square trinomial relationship, which means that I take this squared, I take 3 times x, which is 3x times 2, which is 6x, and then I take the 9 squared. So a lot of people were forgetting this middle term. And that middle term is super, super important. Okay, so make sure whenever you see a binomial squared that you're using this relationship and not doing this, because that is not good. So that brings us to, we'll actually go over that problem. So assignment 4 on the docs was this problem, x plus 3 squared minus 5x minus 15. So basically you had to use your perfect square trinomial relationship to factor this out. Once you did that, you could put your like terms together. So you would get x squared plus x minus 6. This is a trinomial. There's no GCF. So my product is -6. So I have 1 and 6, 2 and 3. Since the sum is 1, I put the negatives here, which gives me this. So x squared minus 2x plus 3x minus 6. Here I group x minus 2. Here I group, I can take out the 3, x minus 2. So I have the x minus 2 here and the x plus 3 here. I got a question that said on the chat, when do you know when to distribute the square number? If you have a times b, when it's a multiplication, then you distribute it to both terms and you would get a squared b squared. But if it's a subtraction or an addition, then you have to use your perfect square trinomial relationship. So the perfect square trinomial relationship says that this is going to be a squared minus b times a, which is ab times 2, plus b squared, and that this one will be the same thing, a squared plus a times b times 2 gives me 2ab plus b squared. So when you have an addition or a subtraction, you have to remember your middle term. So you have this middle term here that cannot be forgotten. This sometimes comes up as part B questions, or part A questions actually. We looked at a couple of those together that says which of these is a perfect square trinomial. And then you have to know what you're looking for. You have to know that you're looking for two perfect square numbers here and this middle term that corresponds to this times 2. So this is an important relationship. Okay. Just one other thing before I get started on the assignment 5 questions. When you're stating restrictions, so we'll take a look at this in a second, but when you are stating restrictions, you state restrictions before you cancel out any factors. Okay, so for instance, if I have, we'll just skip to this part. This is what you're given with. This is the start. You have to state restrictions for both of these. You can't just say, this is not a negative, just to clarify here. You can't say, oh, well, these are going to disappear, so I don't have to deal with this as a restriction. You do have to deal with this as a restriction. You have to say, number 1, x minus 3 is 0, x is 3, and number 2, x minus 2 is 0, so x is 2. So your restrictions are x cannot be 3 and cannot be 2. Then your answer, solution after you do the canceling is x minus 5, x minus 2. Now 3 is no longer a restriction in this new thing, but because it existed in the original expression, you have to include it in your restriction list. So you list the restrictions before you cancel. Okay. So we'll take a look at a couple of the problems on assignment 5. Those were the next ones that were asked. So we'll do number 1. Okay, so I'm going to factor this one. You have to factor everything before you can go, okay? So here we have, what can I take out of the first one? A 3. I can take out an x out of the second. Here I'm going to change this to a multiplication and flip everything. But while I'm doing that, I'm going to factor. Okay, so this is going down here. So what can I take out? There's 3 terms. I can take out 2x squared. And then here what I'm left with is x squared plus 3x plus 2. Here, this one was the trickiest part of this. This is a difference of squares. So I have a squared term minus a squared term. So we get the square root of the first, which is 5x plus 4. The square root of the second, which is 2. And then 1 is plus and 1 is minus. Here, I'll start to factor out whatever I can factor out. So here I can pull out a 6x squared, and I'm left with x minus 1 plus 1. Sorry, this should be a plus. And here I can take out a 9, and I'm left with x plus 4. So this one's factored, this one's factored. I have to manipulate the middle one a little bit more. So if I just recopy this, this I can reduce a little bit. So 5x plus 4 plus 2 is 5x plus 6. 5x plus 4 minus 2 is 5x plus 2. Like I said, this just recopies. Here, I'm going to, you would product sum this on the side, but I'm going to jump that step just quickly here. So you'd product sum this, you would get x plus 2, x plus 1. Now you play that everything's factored. Now you can play a canceling game. So I have 5x plus 2. I have x plus 4. I have x plus 1. I have x squared. I have this 3, which can turn into a 1, and if I reduce it with this 9. I have this 2 that can turn into a 1 if I reduce it with this 6. And then actually, well, the 3's go away themselves too. So then I recopy what I'm left with. Sure, I'll try to slow down a bit. So on the top, I'm left with 5x plus 6 And on the bottom, I'm left with x plus 2. How did I get 5x plus 6? This is a difference of squares. This is the trickiest part because you have the square term here and the square term here. So the difference of squares says I take the square root of the first one, and if I take the square root of this term, that just means this goes away. So I have 5x plus 4 and 5x plus 4. This I square root to give me 2, and then 1 is plus, 1 is minus. So when I have 5x plus 4 plus 2, I add these two together because they're the like terms, and I get 5x plus 6. I do the same thing here, and I get plus 4 minus 2 to give me 5x plus 2. So this was a very, very tricky problem. There were a lot of steps, nothing you couldn't handle. All the factoring we've done before. The only real trick to this was this difference of squares, which was very difficult to see. But other than that, all the other factoring and the canceling was something we have done together before. So always, don't get intimidated, just always follow the same steps that you have followed before. Okay. We'll take a look at number 2. So we don't have much time before we have to start doing work. But here we have x plus 1. X plus 21. Okay. So when you see an addition, you have to put your, annoying. You have to factor everything. Well, whenever you do anything, you have to factor anything. So 5x squared plus 32x minus 21 factors into if we product sum this, you'll get plus 35x minus 2x minus 21. And here, 17. You get 4x minus 1, 2x squared plus 14x plus 3x plus 21. So that's what we've done before in the past. So when you regroup these, just to jump ahead a step, you're going to get 5x minus 3 here. 5x minus 3 and x plus 7. And here you're going to get 2x plus 3 and x plus 7. Yes, I just fixed that myself. Thank you. So here I compare and I say, all right, this has an x plus 7. It has an x plus 7. This hasn't 5x minus 3. This does not. So I have 5x minus 3. When this one's taken care of, then I say, okay, we have the x plus 7. This one has a 2x plus 3 that this one doesn't. So what does that give me? That gives me 2x plus 3 times x plus 1 plus 4x minus 1 times 5x minus 3 all over our common denominator, which is 2x plus 3, 5x minus 3, and x plus 7. You can put these together. I don't expect you to be doing that right now for the purposes of that problem. What I really wanted to see for that problem is, could you factor it properly, and were you able to identify the common denominator and get to this point? Okay. Yeah. I'm just gonna give you hints for number 3 and number 4, just because I'm gonna talk a little bit about that today very quickly. Number 3 says the base of the following prism is a right triangle. What is the expression that represents the volume of the prism? So we know that volume of prism is area of the base times height of the prism. Since the base is a triangle, we have base times height divided by 2, and that's going to multiply, we'll make this a big H, times the height of the whole prism. Each of these things are given to you as an expression. So just to make it easier, write it like this. And then you're going to replace each of these different values by the proper values that are given to you on the triangular prism. That's one big multiplication. You then factor, and then you reduce. A hint for number 4, and we'll come back to it today. You're given the area is SAN over 2. So again, we're going to write this as 1/2, the side measure, the apothem, and the number of sides. So you plug in the information that you know. I'm given that the area is 108. The side measure is 4x minus 3. The apothem is 2x minus 2. And the number of sides is 6. So we talked about solving quadratic equations. So we'll actually just go through this problem. So I'm going to reduce this 2 with this 6 to give me a 3. So I have 108. If I do this multiplication, I get 8x squared minus 4x minus 8x minus 6x plus 6. This is all going to multiply by 3. What I'll do is I'll just divide this by 3. So 108 divided by 3, that gives me 36. Put that together. If I subtract 36 on both sides, this gives me minus 30. Now this is something that we know how to handle. So we factor it. We say, well, actually, I'm going to get rid of a 2 here. I'll divide both sides by 2. 0 divided by 2 doesn't give me anything. So here, my product is 60. My sum is -7. So if you do that on the side, this is what we get. So I'm just going to jump ahead because we have gotten a lot of practice with this. So this is what it factors into. Now we remember on Friday we talked about when we get to this step that we take each of these factors and set them equal to 0 to find the 2 possibilities. So in this case, 4x equals -5. So x is -5 over 4. And here x is 3. Now, the only added bonus you get when you're doing a real life problem or a word problem is that you have to go back to your original problem and say, do my answers make sense? So I have a value of -5/4. If I plug that back into this one here, that gives me -4.5. I can't have them. I can't have a side measure or an apothem that's negative. So this is rejected. And I get x equals 3. And now you have to find the numerical value of the perimeter. So I'll leave that to you. The question on the side says, on the exam, would they tell you to find the restrictions or set the equation to 0, or you have to figure it out? It depends on the question. So like I said, if you see the sentence, given that the denominator is not equal to 0, they're saying, don't worry about the restrictions, we're handling that. If they don't say that, you do, or the question will actually say, find the restrictions. When you're setting the equation equal to 0, it would look something like this problem, where it actually gives you a numerical value and it gives you an algebraic expression to solve. So we'll look at a couple of more of those problems today, very quickly before we move on. Okay. The last question I was asked was the quiz number 2. Okay, so the quiz number 2 says that, I'm gonna put this back, says that you have this, and you know this is the volume of a prism. And we know that volume of prism is area of the base times the height. We just used that. So we actually know that the height here is 2x minus 1. So I'll divide by 2x minus 1. We looked at a problem like this earlier on last week. So this is a long division. Once you do the long division, what you're going to get is some sort of expression, some sort of trinomial, okay? So you're going to get a trinomial. So your solution is a trinomial. From there, you're going to factor the trinomial. And that'll give you the sides of the rectangle. All right. Okay, so we're going to have to move on. If we have time at the end, we'll go back to some more questions, or at the beginning of tomorrow's class. And more specifically on Wednesday, when we actually see each other, we have a bit of time to go over some stuff. So today we're going to be talking about a lot of analytic geometry stuff, so lines and analytic geometry. But before we do that, I want to take a look at this question. Okay. These sometimes come up in a 10-point question. So a question like this. So this would be a part C question, and it's algebra, but it doesn't really show that. So if you read the question, you have this magic trick that someone's performing. And basically you do all these different steps, okay? And you start at a number and you finish at a number. So they say the number in step 1 and the result in step 6 are the same number. Prove that this trick works for any number. So if you're proving for something, so our test, if you're proving something works for any number, you have to prove it algebraically, which means we have to start with x. So basically here we have step 1, we chose x. Now we're going to follow each of the steps as she did, but with x. So step 2 says that we multiply the number chosen in step 1 by 10. So we get, 10x. So we're hoping after all these steps, we're going to get back with x. 3 says add 9 to the product obtained in step 2. So we add 9. Step 4, add the square of the number chosen in step 1. So this is our step 1. So we square it to the sum obtained in step 3. Step 5, divide the result in step 4 by the sum of 9 and the number chosen in step 1, meaning x plus 9. So here I would say I would do my long division. So I would have x here. This multiplication gives me x plus 9. X. I subtract, and that gives me x, and I bring down the 9. So that gives me plus 1. Multiplying here gives me 0. Step 6 says subtract 1 from the quotient obtained in step 5. So we're taking x plus 1 and we're subtracting 1. That gives us our x back. So you would say, basically you would say, prove that this trick works for any number. You could write a sentence at the end saying we started with x, we ended with x. Therefore, x could be any number. So it really doesn't matter. If I plug in x as 2, I should get 2 back at the end. If I plug x in as 1,000, I'll get 1,000 back at the end. Because whatever I set x to be, after I do all of this stuff with numbers, I'm going to get x back at the end. So these type of problems do come up on final exams. So basically, if you see prove that this trick works for any number, you're doing it algebraically and you're just solving it one by one. Not too bad. Okay. So basically, in the notes, I gave you a whole bunch of information. So if you look in the notes, there are like 30 or 29 pages. Not all of this is new material. I want to stress that. I included all of the notes that I had for analytic geometry. So today we're doing analytic geometry and lines. So things like division point, things like midpoint, things like parallel lines, perpendicular lines. These are things that you went over in your CST class. So we're not going to go over them together because we just have to cover the stuff that you didn't look at. But in this package, there are pages here where I give you notes on the distance formula and midpoint and division point. Like I said, we're not actually going to look at those together, but it just gives you a little refresher for all of those things all kind of put together as one. So we will look at some of the line stuff together and some of the new stuff. But like I said, we're not looking at parallel perpendicular, so you can just look over these notes and try the examples that you have there. This will be a good refresher for you for analytic geometry. And I'm going to let you know that the review package for today is the same situation. So if I go to the handout that will be posted later today, you have 30 pages, okay? Don't get overwhelmed. There are like 50 questions and some extra pages, but a lot of the material is repeated. So what I would recommend is that you go through and look at the questions that are new. So you'll see when we do it together which questions, like what kind of stuff is new and what is not, and then try those problems. But these are all practice analytic geometry problems that have to do with division point, distance, midpoint, slopes, parallel, perpendicular. So a whole bunch of different stuff put together, plus the new material, and you have the solutions for all of it. So this stuff is really good practice for the final as well, because analytic geometry is completely fair game, everything from start to finish. Okay. So the last thing that we didn't talk about last week that we kind of got into this morning were solving second degree equations involving word problems. So the last thing that we did together was solving second degree equations, but like the problem that you had on the assignment where it was a word problem, we're going to look at a couple of those together before we move on. So for instance, the only added extra issue with solving for word problems, there are two of them. One, you're going to have to create the equation yourself, but just like you've done this before with simple algebra and numbers and stuff, so that part shouldn't be tricky. The only part that is tricky is analyzing your answers. So like I said for the problem before, some answers don't make sense. So you have to see, does this make sense for my problem? So here, for instance, we'll do number 2. It's a little bit trickier than number 1. So a triangle has an area, not even reading anything else. Area of a triangle is base times height divided by 2. Not even bothering. Now I figure out what I know. It's telling me that the area is 27, so that goes in as the area. They're saying that the width and height, or base times height, we're going to say is x and x plus minus 3 divided by 2. So I have my equation and the question says solve for the value of x. No different than normal. I'm going to multiply up here. That gives me 54. This gets multiplied in. I get x squared minus 3x. And then here I get x squared minus 3x minus 54. Now remember, when you're solving equations like this, you're factoring. So I'm just going to skip this step because this is something that we can't spend more time on. But here, if you do this, you're going to get x minus 9 and x plus 6. You split this into your two equations. So you get x minus 9 equals 0. Remembering we set each of the factors equal to 0 when we're solving. So we get x is 9. X plus 6 equals 0. So x is negative 6. So in theory, we would be done and we would say negative 6 and 9 are our possibilities. But if we go back and we look at the problem, it says that the width of the triangle is represented by x. Does it make sense to have a negative width? No, that's impossible. So we have to reject this answer, and actually our x is 9. So the added step, like I said with word problems, is that you have to go back and be sure that your answer makes sense. Any word problem involving second degree equations is always a reject accept type problem. So in theory, you could get two answers that you would accept, but you have to check. So if I look at the 9 is x. So that would give me, the base would be 9, the base, and the height would be x minus 3, which is 9 minus 3. That gives me 6. So both of these are legitimate answers to have for this type of problem. So 9 doesn't give me any issues. This is my answer, and this gets rejected because it doesn't make any sense. We'll do another one. Okay, do number 3. The product of the first and third integers of 3 consecutive positive odd integers exceeds 10 times the middle integer by 7. So this one's super wordy. But we have all the tools that we need to solve this problem. So the product of the first and third integers of 3 consecutive positive odd integers. So I have int 1, int 2, int 3. So I don't know what any of these are. So if I call the first integer x, consecutive positive odd. For example, you would have, if this is the first one, it would be 3. The next odd number is 5. The next odd number is 7. So, or if I have 11, 13, 15. So to get from this to this, I'm doing plus 2. And to get from here to here, I would add 2 again, which is x plus 4. The product of the first and third integers, so one side, the product of the first and third integers exceeds is saying that it's the same thing as 10 times the middle integer. 10 times the middle integer. This is 7 more than this. So I'm just going to add 7 here to make them equal. I have to remanipulate this equation. So this becomes x squared plus 4x equals 10x plus 20 plus 7. Now I know again that I'm going to manipulate this equation. So I move this over, I get negative 6. That gives me negative 27. So again, you're at this step, you product sum because you have one side equal to 0, skipping the product summing part of this. Those are the two answers that I get. So here I solve, I get x minus 9 equals 0, so x is 9. And here I get x plus 3 equals 0, so x is negative 3. Now I go back to my criteria at the beginning that says what type of integers I have to see if my answers make sense. So it says the first and third consecutive positive odd integer. This is not positive. This cannot be my answer. So I accept x is 9, meaning that the first integer is 9. The second one's going to be 11, and the third one's going to be 13. So this isn't any different than we looked at before with just solving second degree equations. It's just that you have the added bonus that you have to analyze your answers. In math, you should always be analyzing your answers because when you have word problems and real life situations, sometimes there are answers that don't make sense. For instance, you have a problem, doesn't make sense to end up with 0.5 of a person or 0.6 of a battery because you can't have those things. So always remember when you're doing any type of word problem that you need to analyze your answer to make sure it makes sense. But specifically for these type of problems, because you are going to get an answer, 95% of the time you'll get an answer that one of them you'll be rejecting. So you need to know which one you're rejecting. and which one you're rejecting just has to do with, does it make sense with the problem? Okay. All right. So we're going to move on from here. Now we're going to be doing analytic geometry. So I'm just going to take a quick look here. I'm going to show you the slides that we're not going to go over that you should know. Okay, so the first one is distance between 2 points. So you have this formula. Again, I'm going to put up a memory aid soon just to help guide you, but this is something that should be on your memory aid. So we have this distance formula with a couple of problems to help you remember how to do it. We then have the midpoint. You have your formulas here. And then you have some problems here for midpoint to help you remember how to use midpoint. Then you did division point. So first it reminds you about the fraction here, how you have the m and m plus n. So depending on how your information is presented to you, you either plug this in as m and n or you plug it in as the whole fraction. The question on the side chat says you're going to put all of the CST stuff on the memory aid. So what I have is an example memory aid for TS, so for the class that you're taking. So on that memory aid, it's going to have everything for the whole course and not just the new stuff that we covered together. So it gives you an idea. It's not perfect. It's not personalized. So memory aids, like you know, are very personal. There are sometimes examples that you need more than somebody else would need, but you need kind of all the same formulas. So it basically just provides you with the formulas that you'll need. So we'll take a look at that together probably on Wednesday. I'll upload it. That way we can take a look at it together in class and just understand what kind of memory aid it is and what you need. You can copy that stuff to your memory aid. You can add, subtract, add problems. Sometimes that memory aid, it's not as straightforward the way it words things or like words formulas. So you just have to be weary of it. Like you just have to make sure that you're not just copying something for the sake of copying it. You need to make sure that you understand what you're writing. So like I said, we'll take a look at it together on Wednesday and I'll show you what I mean by all of this, and then you can start working on your memory aid, because you are allowed a memory aid for the sit prob next week and obviously for the final. Same deal, handwritten, 1 sheet, 2 sides. It's happened to me before where someone's typed it and I had to take it away. Or that there were 2 sheets. If there are 2 sheets, I'm ripping one off. Like we have no choice. It's very, very strict guidelines. So make sure you remember that. But it's the same guidelines as you had for the CST final. So everybody should be used to that by now. So we have distance, midpoint, division points, and then some division point problems. So here we are with slope of a line. Okay, so here the blue I took out, so you could take the time to copy this down. This is like really, really, really review. So I'll give you 30 seconds, 1 minute, 2 minutes to copy these down, and then we'll just talk about this for a second. So just while you're finishing, there are 4 different cases to slope of a line. So in this picture, it gives you the 4 different cases. So you have positive slope, which is the one in red. You have the negative slope, which is the one in blue. So positive meaning as we go from left to right, I'm increasing in my values. The blue one meaning that as I'm going from left to right, I decrease in my values. That indicates a negative slope. A zero slope is a horizontal line. The rule is y equals b, so it's whatever the y value that it hits. So in this case, that's the green line. And then we have what we call an undefined slope, which is a vertical line. We have the rule x equals c, example, where the line crosses the x-axis. And in that picture, that's the orangish yellowy line. So those are the 4 different types of lines that we can have, just as a general reminder here. We good to go? Okay, so we're going to talk a little bit about lines first. There are 3 different pieces that we have to put together today of new material. So lines are going to be the first thing that we're going to look at. So just a couple of reminders here. We have the functional form of a line, which is y equals ax plus b. So you learned that in secondary 3. What do you mean there's a price still in fill in? Oh, here, the slope. Sorry, the formula. Go back. Okay. So this formula should be old news now. We do use that like crazy in secondary 3. So just remember here, functional form, you have y equals ax plus b, where a is the slope calculated by this formula, y2 minus y1 over x2 minus x1, and b is the y-intercept. So just a reminder for intercepts, this comes up a lot in analytic geometry problems. An x-intercept has the form some number and 0, example 6 and 0. And a y-intercept has the form 0 and y, for instance, 0 and 10. This is going to become actually really important for the line thing that we're going to be talking about today. Graphing you should be used to. We're just going to copy these down. Most of you should have covered general form of a line in your classes this year, but just in case if there are any of you that didn't cover it formally, we're going to cover it formally together very, very quickly, however. So just copy down the blue very quickly and we'll keep moving on. I had a feeling there might be one or two of you that haven't. So we are going to go over it. Some teachers cover this with the CST, some teachers don't. That's why we're just going to make sure we're all on the same page. Okay. So with lines, you have the functional form, which is y equals ax plus b. So even if you haven't talked about general form specifically, you've kind of used it when you did system of equations and elimination method, so that you definitely did. But this is just formally saying that this is actually a form of the line and what it means. Goodness, I'm writing all over this. So general form of a line, basically general form and functional form are just different presentations of the same information. So general form of a line has the form ax plus by plus c equals 0. For example, 2x plus 5y minus 7 equals 0. So that is a line that we can graph. So just to give us an example here. Two x plus 3y minus 7 equals 0 just presents as a line. Okay, so even though it looks different, it's still a line. Now, you have functional form and general form of the same line. Okay, so the y equals ax plus b and the general form, you can find the equivalent representation and you're graphing the same line. For instance, if you have this, notice how one of these is in y equals ax plus b form, one of these is in general form, but we're just graphing the same line. So it doesn't change anything for me, it just changes the fact that I'm representing this differently. Why do we do this? Well, first of all, let's talk about the criteria for having general form. A, B, and C have to be non-zero whole numbers. Whole number being the most important part of that sentence. A has to be a positive number. A and B cannot both be 0, obviously. And one side of the equation has to be equal to 0. So to have true general form, you have whole numbers, A positive, and one side equals to 0. A line can have many different general forms. So if I go back to this representation, move this here. So here I have this general form. I can change this. 9y minus 21 equals 0. So notice here I have general form. Here I have general form. And I'm still graphing the same line, but I have two representations of it in general form. That's okay. But notice that once to get from here to here, I multiplied each of those terms by 3. I could do it again. I can multiply them by 10. As long as I'm multiplying by the same number each of the terms, I'm going to have the same line, just represented with a different general form. To get the slope out of here, we have negative a over b. So again, if we go back here, if we compare the first two, negative a over b in this case would mean I take negative 2 divided by 3, and that's the slope of this line. But if you look here, that's what I have, negative 2 over 3. So that's just a formula to help us extract the slope from this form. Benefits of using general form is that it doesn't deal with decimals. A, B, and C have to be whole numbers. And it's super, super easy to solve for intercepts in this form. So when we're calculating, we're just gonna, this is just like to give you information about different types of general form, but it's not really important. So if we calculate intercepts in general form, always with intercepts, we're setting y equals 0 or x equals 0 to solve for the intercept. So with this form, it's super easy. So we'll see this. Well, I'll let you copy this down before we get to the examples. So just something that you could have to do, you could have to convert from general to functional or functional to general. So both of these are very straightforward. So if you're going from from general to functional, you need the slope, the y-intercept, and you put it together. If we're going from functional to general, we have to abide by the 3 criteria for general form, meaning we have no denominators. One side has to be 0 and a has to be positive. So we'll do a couple of examples of these and of calculating intercepts to see the benefit of using general form. You can hear some kind of tapping, so someone's not muted. Check your muting, please and thank you. Thank you very much. All right. Cool. So we'll do a couple of examples here. So first, we remember what general form looks like. Now we're going to convert to general form. So basically, when we're converting to general form, Miss, would you be able to post the class 7 notes after your second class, please? Yeah, they're going up at 1 o'clock. Convert the following line to general form. So we have 3 criteria that we need to follow. First says no denominators. So here I have no denominators. That's fantastic. Criteria 1 is good. Then it says a has to be positive. So in this case, a is positive. And then it says one side needs to be 0. So because a is already positive, I'm going to move this over. I don't want to move the a. So I get 0 equals 2x minus y plus 3. And that's general form. Just put a negative in front of there just to make an adjustment to this problem. Okay, converting this one to general form. Same 3 criteria that we have to follow. So we need to get rid of this denominator. So what I'm going to do is I'm going to multiply the entire equation by 3. So in this case, I get 3y. Negative 2 times 3 is negative 6. Divided by 3 is negative 2. And 3 times 5 is 15. So I've gotten rid of my denominators. That's not a problem. Now I look. Right now my a is negative, so it needs to change. So when I move everything to one side, I'm going to move this stuff to this side. So I get 2x plus 3y minus 15 equals 0. And this is general form because we have no denominators, a is positive, and one side is 0.
Miss?
Yes.
So for B,
hold on 1 second. I can't.
Yeah.
My volume's too low. Go for it.
So for B, that equation you multiplied it by 3. Why? Why did you multiply by 3?
Because we need to get rid of the denominator.
Okay, so you have to multiply it by
whatever the denominator is.
Okay.
Okay, because if you multiply it by whatever the denominator is, it ends up canceling out. So notice how this 3 went away with this 3, and we just were left with the -2. That's what we want because we don't want any denominators.
And yeah, okay, that's all.
Okay, perfect. All right. So using the rule of the line in general form, we're going to calculate the y-intercept, the x-intercept, and the slope. So we'll start with A. So the reason this is easy to solve for intercepts is because when we are doing intercepts, we are setting something to equal to 0. So when we're doing the y-intercept, we're saying x is equal to 0. If x is equal to 0, this whole term here goes away because 3 times 0 is 0. So I can just erase it. This is called the hide and seek method. So you're just hiding that part of it, and now you're solving this equation for y equals -8. So y is -2. So it's very, very easy to solve for intercepts in this form. B, same idea, 3x plus 4y plus 8 equals 0. If you're solving for the x-intercept, that means y is equal to 0. If y is equal to 0, 4 times 0 gives me 0. So this entire term just goes away. And I'm left with 3x plus 8 equals 0. So 3x is -8. So x is -8 divided by 3. So in general form, we do the hide and seek method, meaning that depending on which intercept you're solving for, either this is going to disappear or this is going to disappear. See the slope? If you go back here, you have a formula for slope. It's -a/b, so that's what we're going to be using. So here the slope is -a/b. So a is 3, b is 4, so the slope is -3/4. So some things are actually almost easier to do with general form. It turns negative. Okay, so the question is, how come the number with no variable always turns negative? When I move this to the other side, it changes signs. So here, same thing. When I move this to the other side, it changes signs. So that's just the idea of solving equations. Okay, so we're just going to do one more example. Convert the following line to functional form. So the method is very easy, okay? I don't like easy, saying easy, but whatever. My bad. All right, so for functional form is y equals ax plus b. So there are two things I need for functional form. I need the slope and I need the y-intercept. So slope is -a/b. So slope is, this is a, this is b, that's my slope. 2, I need the y-intercept. So x is 0. So again, we're going to solve just like we solved there before. So we remember if x is 0, that means this term is going to disappear. So I can just erase it. And I'm solving this. So if I move this over to y equals 6, dividing by 2 gives me y is 3. So if I have functional form, I have y equals the slope and the y-intercept. Not too bad. So that's the easiest way to do this. So general form can pop up in different types of questions. So it can pop up in parallel perpendicular questions where you actually have to use this slope. So we remember parallel perpendicular just very quickly means that for parallel lines we have the same slope. For perpendicular lines we have negative reciprocal slopes. So you have to be able to extract the slope from general form. So in this case, this formula becomes super important for you. And then sometimes the problems with parallel and perpendicular, your answers, let's say you get it in a part A question, instead of your answers being in functional form, they could be in general form. So you just have to really know how to work with general form. Really, the most important thing is finding the slope and finding the two intercepts, especially the y-intercept. So those two things are super, super important, okay? All right, so we have another form of lines. So you have functional, y equals ax plus b. You have general, and then you have a third form of a line. So this is definitely new. Unless your teacher decided to cover it this year, we should be into the new material now. All right, so symmetric form. Symmetric form of lines is used for lines not passing through the origin. So it's very easy to construct if you have both intercepts. So basically, your A, I'm going to put this into 2 dots because it's not a negative. Your A value is the x-intercept. The B value is your y-intercept. The slope is negative b over a, and one side has to equal 1. So for example, you can have x over 5 plus y over negative 3 equals 1. What this means is, here, theoretically, your x-intercept would be at 5, and your y-intercept would be at negative 3. And you can literally just join these two by a line, and that's your line. So theoretically, you have the 3 different types of lines here. You can have all 3 different forms, okay? So if I have y equals 2x plus 6, the general form of that would be 0 equals 2x minus y plus 6. Still graphing the same line. And the symmetric form of this would be x over 3, negative 3, plus y over 6, equals 1. So we have the 3 different forms, all representing the same line. So this is obviously more straightforward in the sense that like you just need 2 values and you're good to go. So what you could have to do with this is you could have to convert. So I'll do a couple of examples of those very quickly. So just as you're finishing copying, when you're converting forms, the important thing is to remember the criteria for each form. So for a functional form, y has to be isolated and have a coefficient of 1. For general form, you can't have denominators. One side has to be 0 and a has to be positive. For symmetric form, you need the 2 intercepts on the bottom of the 2 variables, and you need one side equal to 1. So basically, you just have to remember all the different criteria. And then from those criteria, just you convert one thing to another. So let's do a couple of examples here. So for this first example, so you're given the following rule. It's a bit better. So here you want to find the slope. So just like before, you have a formula for slope, except in this case, it's negative b. You're not finished copying, sorry, going back. Awesome. So you have this rule for your formula. So here in this case, I take negative, my b is 12, my a is negative 4, 12 divided by 4 is 3, negative, negative gives me a positive, so this is my slope. The x-intercept is negative 4, because the x-intercept is whatever number is underneath the x. The y-intercept is 12, so this is x is 4, y is 12, because it's literally whatever number is underneath the y. That's it. Convert to standard form. I have the slope, I have the y-intercept, so y is 3x plus 12. That's all you got. Converting to general forms a little bit trickier. So if I have x over negative 4 plus y over 12 equals 1. So what I'm going to do is I'm going to multiply the whole equation by something that'll get rid of both denominators at the same time. So I can't multiply by 4 because that won't get rid of this. But I could multiply by 12 because that will cancel this out and this out simultaneously. So this distributes to all terms. So if I multiply this by x, so 12x divided by negative 4 is negative 3x. If I multiply here, 12 divided by 12 gives me just 1. And here 12 times 1 is just 12. So now we have no denominators. In general form, we need to have one side that's 0 and a that's positive. So I look here and this says negative 3. So I want to fix that. So I'm going to take this side and plop it over to the other. So the 3x becomes positive, the y becomes negative, and the 12 stays. And that is general form. Okay. So if we look here, y equals 3x plus 6. X divided by -4 plus y divided by 12 equals 0, 1, sorry. This was 12. So we have these two that are the same, and now we just had this general form where it was 3x minus y plus 12 equals 0. So you notice we have the three different forms, and they're all representing the exact same line in the Cartesian plane. So all of these three forms are acceptable. So if you have a final answer that's in any of these forms, because they're exactly the same representation, as long as you've got the right one, doesn't matter, you're fine. So this, we're just going to talk about it. We're not going to do any examples. So you have the blue part to finish copying, and while you're copying, I'll just give you a quick overview. So finding the rule of the line, like I said, all three different forms are acceptable when you're presenting answers and such. But the idea is that depending on what kind of information you have, you're going to use one of the forms because it may be easier that way. So the only form you're not going to use if you're calculating the rule of the line is general. Because general form, there's no way to find that representation quickly, so you can't do that. So you could use either functional form, which is the y equals ax plus b, or the symmetric form, x over a plus y over b equals 1. Either one of those are totally acceptable, and depending on what kind of information you're given, one of them is easier than the other. So if you're given 2 points, you're going to be using y equals ax plus b. If you have a and a point or b and a point, so I'll just do one of these big things here, you're going to be using y equals ax plus b. But if you're given the 2 intercepts, you're going to use this one because it's easier to use if you're given the intercepts. So situation 1, 2, and 3, that's stuff that you do in depth in secondary 3. So we're not going to take a look at that again because you do it in secondary 3 and you do it a lot in secondary 4. So in theory, you're good to go with that. Can I move on? Have we copied? Any objections? Okay, cool. So we're just going to go to the example here, number 4. So find the rule of the line that has an x-intercept of 6 and a y-intercept of -3. So as soon as we see the intercepts, you want to use symmetric form, which is x over a plus a y over b equals 1. The a is the x-intercept. The y-intercept is the b, and we're done. So rather than going through functional form, calculating the slope, finding the b, blah, 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 this is a perfectly acceptable answer and you're done. The only added bonus is sometimes, rarely, but sometimes, they'll say find the equation of a line in general form or in symmetric form or in functional form. They'll tell you which form to use. And in that case, you still start off with whatever form is easiest based on the information you're given. For instance, here you would go functional and then you'd have to convert to general using the conversions that we just practiced. Okay. So those are forms of a line. So what we are going to be doing next is another tool specifically for analytic geometry. So just quickly here, you have parallel lines with these type of questions involving general form for your slope. So take a look at those. Perpendicular lines, same thing. You cover this in depth in CST as well. The different positioning of lines, so you have parallel, perpendicular, and coincident. This is where we get to new material again. So I'll let you copy. So it's distance, point to line. Okay, so here we go. You have different tools to do different types of calculations in Cartesian planes. So, for instance, you have the distance formula, then you have midpoint, you have division point, you have all that line stuff you can do. This is an added tool. So this again is new material. So this is distance, point to line. So what you are doing is you're taking a point and you're finding the shortest distance between a point and a line. The shortest distance is basically if you have a line and you have a point, the shortest distance between this point and this line is where, if I connect them, is wherever it's going to meet at 90 degrees. So that is going to be the shortest distance. Because sure, I could connect this here, I could connect this all the way down here, but that's not the shortest distance. Like if I say I want to know how far I am away from the door, I'm not going to go through every desk in this classroom to get there. Like I'm going to walk to the door. So I want the shortest distance. So to do that, you need this formula, which you don't have to memorize. That's what memory aids are for. So to do this, you need the line in general form. So this is your general form, remembering ax plus by plus c equals 0. You're going to plug in your values and calculate the distance between point and line. So if we're calculating the distance between this point and this line, as soon as you see point to line, you automatically go to your formula. So you have ax plus by plus c equals 0 divided by a squared plus b squared. Now I just want to go to this formula for a second and talk about what these lines mean. What those lines mean are absolute value. What those lines do is they turn everything positive. So you can't have a negative distance. If I say I'm 10 meters from the door, I'm negative 10 meters from the door. What does that even mean? It makes no sense. negative 10 meters from the door. I'm either 10 meters from the door or I'm not. So your answer cannot be a negative number. So basically what these mean are if you end up with a negative number in here, your final answer, not negative terms, those are fine. But if you put this whole thing together and you get a negative number, then you just drop the negative. So let's take a look at what happens here. So here I plug in my points. So I have 3 as my A, 2 as my X. I have 4 as my B, because here this is in general form. I have my Y as -1 and my C is -12. I have those special brackets that I'll be using. And on the bottom, I have A squared, which is 3 squared, and B squared, which is 4 squared. So here I get 6. Here I get -4, and I have -12 all over the root of 9 plus 25. 16. Woo! Little brain malfunction there. Plus 16. Continuing up here. 6 minus 4 gives me 2, minus 12 gives me -10. And this gives me on the bottom the square root of 25. Now, like I said, because of these magic little absolute value brackets, the negative disappears and it just gives me +10. The square root of 25 is 5, so that just gives me 2 units. So the shortest distance between this line, this point, and this line is 2 units. We're going to skip to number 3. Calculate the distance. Can I go back up here? Yeah. We good? All right. Okay, we're going to do number 3 and number 4. So here we're going to calculate the distance between parallel lines, and you're given these 2 parallel lines. This is tricky because it doesn't actually say, the problem with distance point to line is it doesn't always say use distance point to line. Right now you're calculating the distance between the parallel lines. So what we know about parallel lines is they're never going to touch, right? So we've got, let's say these 2 parallel lines, they're never going to touch. So the thinking is, if I take any point on this line and find the distance, then it's going to be the same distance forever. So I'm going to choose a point on one of the lines. I don't care which, one of them. So on this one, I'll choose x is 0, just because my life becomes a lot easier if I use a 0. So on this line, 3x, y minus 6 is 0. 3y equals 6. So y is 2. So on this line, I have 0 and 2 as a point. So what I'm going to do now is I'm going to use my formula to calculate the distance between, why is that an equal sign? Silly, silly. A squared plus b squared. So now I'm going to plug in, I'm going to use this point with this line. So my A is 4, but my X is 0. My B is 6, my Y is 2, and my C is 3. And then I get 4 squared plus 6 squared. On the top, I get 6 times 2, which is 12, plus 3. All over 4 squared plus 6 squared gives me 52. The 12 plus 3 gives me 15. The root of 52 gives me 7.21. And I can just divide because 15 is already positive, so I can just take these away. It's not going to impact my answer. So then my final answer is 2.08 units. So that is how far apart those two parallel lines are. Give you another second to finish copying it down. Cool. This is an example of, again, it's not going to tell you that you need to use distance point to line, but you figure it out. So consider the parallelogram ABCD below. We have 3 different points. We want the area of the parallelogram, okay? Area of the parallelogram is base times height. The height being the measure that meets at 90 degrees. So for this problem, we need 1, the equation of line AB in general form. For number 2, we need, our second step is going to be distance point to line using B and AD. When I said AB, I just totally lied. AD. And then 3, I need the distance of AD. And then 4, I need to calculate the area of the parallelogram. So, unfortunately, we're kind of running out of time here. So we won't have time to do this problem completely. So I'm going to leave you with those steps. Try it out. I'm going to start with this problem tomorrow. Just so you know, lately I've been waiting a couple of minutes after 10:30 just to make sure everyone logs on and is on time. But we're like running out of time here every class. So tomorrow I'm starting at 10:30 sharp. So be on the Hangout by 10:30, absolutely super sharp, okay? Just quickly also before you go, so like I said, you have this handout. Specifically focus on anything that you see that has symmetric form of lines. So like here, this is a symmetric form, but you can't do that one yet, so don't do it until tomorrow. But there are different questions that you see symmetric form. Try those out. Other than that, those are a lot of, I'm at 8:30, definitely at 8:30, sorry guys. 8:30 sharp tomorrow. So these are all analytic geometry problems that you could expect to be able to handle on the final. For instance, a line perpendicular to line L, but you're given it in symmetric form. So you have to identify that using the slope and such. So a lot of these are really good practice. Anything you see that looks like this, we haven't actually talked about yet. We're going to talk about that first thing tomorrow. So you can skip those over for now. The last two things as well, but this page is specifically distance from point to line. So you could definitely take a look at these 10 problems, super, super important. Yes, we're gonna cover half planes tomorrow first thing. The other thing is on the assignment, stream group 1, on the assignment, your assignment will be posted very, very soon. Something that just got posted is there are some problems that are helpful to know. These are some relationships in analytic geometry. So a couple of those problems, you're given a quadrilateral and it says, prove this is a right trapezoid or prove this is a parallelogram. So these have the different types of shapes that you should be able to handle with the different tools that you'd use in analytic geometry. So for instance, if they said right trapezoid, you'd be using parallel perpendicular. If they say rhombus, you're going to be using distance and parallel lines. Okay, so this is just a tool for you. You can take a look through it, and if you have any questions, let me know. For the assignment that's going to go up in a bit, there are some questions on half planes. So skip those for now. Save them. I'm only going to give you feedback for this assignment on Wednesday anyway, so you can skip anything to do with half planes, and then we will look at those tomorrow. If there's any questions between now and then, feel free to email me. Otherwise, I will see you all tomorrow at 8:30 sharp.
Thank you.
Thank you.
Have a good afternoon.
Thank you.
You're welcome.